So I'll take you through the history of Six Sigma and Lean, and then quality concept, what quality gurus are saying about quality, and what it actually means to us in our business. And there are several frameworks available to achieve the quality. Balanced scorecard is one framework, and same way we are going to understand the Six Sigma framework, which is a DMAC. And then we will talk about what is the exact difference between Lean and Six Sigma. What is Lean? What is Six Sigma? And why should we integrate them? We'll touch that. And then the belt levels already explained to you. You also asked me a lot of questions about it. Anyway, I will again go through that. And finally, what is Six Sigma methodology and key steps within the Six Sigma methodology of DMAC. This is the overall course outcome. So all of you are going to become a black belt. That means you will be equipped to lead black belt projects. A complex cross-functional project you will lead. And if you go through the program with full involvement, definitely all of you will clear the black belt examination with very good marks. And yeah, madam was talking to you about this particular thing. So what is that you are going to get by going through the black belt program? You will see a drastic transformation in your problem solving ability, right? You can solve problem in whatever, there are several ways, but one way is Six Sigma way of problem solving, which is nothing but systematically solving the problem, right? Fixing the problem at the root level. That is called the Six Sigma way of problem solving. So you will gain an absolute clarity on how to approach a problem, and then how to identify the root cause, and then how to fix the problem at the root level. If you do it, what will happen? The problem is solved forever. The same problem will not come again, right? So this is called the Six Sigma way of problem solving. This is one important, the transformation all of you will undergo. And another thing is the way you take decision. Do you take decisions based on simply opinions, or do you take decisions based on fact? Fact and opinion, there is a clear difference. You will be equipped to draw a clear boundary between opinion and fact. Opinion can come from your boss, can come from an expert, can come from the customer, can come from colleagues. But who is responsible for solving the problem? You are responsible. So you should not react to all the opinion. Rather, you must try to understand whether the opinion is just an opinion or a fact. For that, you must use data. For that, you must use data, because data will let you understand whether the opinion you listened is a fact or not. At the same time, sometimes your data might give you a false alarm. Sometimes my data can give you a false alarm. If the person who collects the data for you, if he is very ignorant, or if he doesn't understand the significance of why are you asking the data, he might give you a data having a lot of error. If the data has a lot of error, do you think the data will help you to understand the fact behind the problem? No, right? And so we are also going to equip you when to use the data and when not to use the data. If the data comes with, the data is free from error, then data will speak the fact, and then we'll use the data. If the amount of error is beyond control, beyond certain specified level, we will safely ignore the data, and then we'll go for a fresh collection of data. So this is what is called a decision making skill. A tool called p-value will help you to understand whether you can use the collected data or not, right? Whether the data conveys a significant information or not. The tool p-value will help you understand, and you will be mastering it in the analyze phase. And then the third thing is you will be equipped to make a right choice of the tool always. Be it whatever work you are doing when you are in a project mode. And it is important when you are working with the physical tool also. Like, imagine you want to machine a component. What kind of machine tool will be suitable? Is it the lathe will do, or the shaper will do, or the milling machine is required, or a high precision machine tool is required? It's very important you make the right choice, right? Same way, your all work related to quality control, all work related to project management, all work related to team management, or anything related to decision making, you need to use the appropriate tool. If you make a wrong choice of the tool, you may be able to achieve some result, but it may not be appreciable by your top management, right? If you always, if you wanted to produce results, which is appreciable by everyone in the company, you have to make a right choice of the tool. You will be equipped on QC tool. You will be equipped on decision-making tool, no, to a great extent. At the same time, we will touch on the team management as well as the project management tools, right? And then your approach, you will always will appreciate having a customer centric and process centric approach at any stage of your project or at any point of time in your professional life. You will always have a customer centric and process centric approach. For example, right now I am delivering a session. Now my focus is on making all of you learn. That's it, right? Because you are my customers as of now. You are my customer as of now. So who is your immediate customer? That you must understand. Customer, there are different types of customer. You are going to learn it in the defined phase. There is a term called end user. The one who buys your product and pays for it, he is called end user. But is it your product you produce and it only reaches your end user? No. There are intermediate output, and as a result of a sequence of process, your end product is produced, a service is offered. But before getting the final shape, there are intermediate output. And now who is the immediate customer of a particular intermediate output? So you should have a clear idea about who is going to receive it next, and he is considered your immediate customer. Only by continuously fulfilling the requirements of the immediate customer, you must try to fulfill the end user's requirement. Otherwise, quality cannot be great, right? And similarly, being result oriented is a requirement nowadays, I understand. But you as a professional, you must be devoted to the process, because it is the process that produces the result. There is no point simply jumping onto the solution every time. There is no point simply focusing on the result every time. You focus on the process improvement, and result improvement will automatically happen, right? So this is what all of you will definitely understand in a long run. Maybe in a short run, you wanted to produce results faster. There are goals, there are targets that will put pressure on you to think only about the result. But there is a point where you will really become matured enough to understand that only processes produce result, and so your focus is fully on process improvement. Six Sigma is a strategy or a methodology for process improvement. You master it and improve the processes, at least the critical processes in your company. Automatically results will improve. If you do all these things happen, you will become a leader in your organization. You will be seen as an asset in your company, right? So these are the things, right? This is the profile, right? So how it all started? It all started from a company called Motorola. In World War II, Japan was badly hit, isn't it? Nuclear bombs thrown, and then the economy was down. The industries do not know what to do next, and there were no proper education, or the resources are also spoiled, and they were in complete dark how to run the industries, and then how to produce quality products and again regain the market. So a set of experts from America, they guided the Japanese that time. Primarily they are Edward Deming, Joseph Zeron, Walter Shewart, and Jenichi Takuchi. These are some people who helped in the initial stages to help the entrepreneurs and the industries to understand the basic quality principles and the strategies towards continuous improvement. And as a result, Japan started regaining the economy, and it has gone to the extent that Japanese products started coming out with world-class quality, right? Their products and services were having greatest levels of quality. In fact, some point of time, they have become better than the Americans. They become better than the Americans, and the Kaizen business model was very famous with Japanese. So somewhere around 1980s, things got reversed. An US-based company called Motorola, was manufacturing televisions in the brand name called Accuser. And that point of time, the Accuser was having a lot of quality issues. When your product has a problem, or a defect in it, and if you still sell it to the customer, you know what will happen? Customer will anyway detect the failure, right? Customer will anyway detect the failure and then make a claim. When a customer detects a failure in your product, in Six Sigma we call it external failure. Why do we call it external failure? You could have detected it proactively in-house, but you failed to do it. As a result, your customer has detected it, right? And since the failure is detected outside of your organization, that is called external failure. So which is dangerous, more dangerous, the internal failure or external failure? The external failure is more dangerous, because when an external failure happens, then correcting it will be very challenging for you. When the product is inside your factory, you have all the resources readily available to sort out the problem. But when the problem happens at your customer's client, can you carry all your resources to sort out the problem? Difficult.
No.
Instead of spending 1 rupee to correct a problem, now you will spend 10 rupee to correct a problem. So these kind of things were happening in Motorola at that time, and they really do not know how to control. Why they do not know how to control? They really do not have a monitoring mechanism. There is no system in place. If there is a system in place, at least the system will detect the failure. If the system detects the failure, at least you will not send your product outside. But product is sent to the customer with all the defect, means there is no monitoring system, there is no control system. That means they were more reactive in approach. They are not having a proactive way of failure resolving. And as a result, there were a lot of warranty claims. The business is running in loss, and Motorola decided to sell the brand. So the Accuser brand was sold and it was taken over by a Japanese firm. The name of the Japanese firm is Matsushita Electric. How they differed from the Motorola is they were proactive in approach. They had approach to detect all the failures internally. Their quality checkings were strict than what it was with Motorola, and then they detected all the failure. If you detect all the failures internally, what will you do next? You will try to solve the failure, isn't it? Maybe you may be inefficient because you have been producing a lot of defects. You are correcting it. You are inefficient. I agree. But you are resolving it. You are detecting the failure. You are controlling the failure. And then you ensure only quality product goes to the market. That means when you are proactive in controlling all the internal failure, it simply means you will make your products defect-free, at least to your customer. Is that clear? Failures are happening within your factory, but when the same product reaches your customer, your products are defect-free. So this is the difference between the Japanese approach and the Americans approach that moment of time. So which is good, reactive or proactive? I think all of you will say proactive. Proactive is good. Proactive is detect the failures before dispatching the product. This is what we call it internal failure. If you keep an eye on your internal failure, external failures will become a rare event. Only occasionally 1 or 2 complaints customer can make, so that you can focus on your job, right? So what happened? There's the same. So what happened? The same product in the hands of the Japanese firm started doing very well. People lot of people loved using the Accuser, but now the Accuser is not in the hands of Americans, not in the hands of Motorola, but in the hands of Japanese. Accuser became very popular and business picked up like anything. So seeing the success of Accuser in the hands of Japanese firm, the CEO of the company, Robert Bob Galvin, he understood one thing. Problem is not only with the quality of the product, problem is mainly with our approach towards quality. I think all of you will agree with me on this, right? This is the lesson Robert Bob Galvin and the entire team learned after selling their brand. So he called all his executives on the same day, like how all of us are discussing today. He called all his executives and then he told them very clearly that we have to see to that our company grows 10 times in the next 5 years. If you really want to grow your company 10 times, then the quality of your offering should also grow, isn't it? This is the indirect statement he passed on to all his executives, and the responsibility was given to two gentlemen. One is Bill Smith. You are seeing him here in the picture. Bill Smith is an engineer by profession, and then Michael Harry, who is a statistician by profession. So both of them were given the responsibility. You know what they did? They developed a system to work, in a proactive way, right? They developed a proactive way of resolving the failure. First of all, when you want to resolve the failure, first you must detect it. How will you detect a failure is happening or not? For example, all of you might know about share market. How do you make the investment? You keep an eye, on the share market with some data. How is the graph is going up and down? And then you take a wise decision, whether to invest, whether to buy your share, or whether to sell your share. All the decision you take only by making use of some data. Same way, they developed a statistical. Working with the data is called statistics. Using data to understand, how are you performing, and using data to take decisions is called, statistics. So they developed a statistical approach, which is metric based. Any number is a metric. For example, now how many of you are on video? Now there are about 12 people. So that talks about, how the program is going on. So likewise, certain numbers when you collect from your, business process, that will tell you how is your process performing. So they developed a statistical metric based system, and as a result, they started detecting all the failures, not reactively. They started detecting all the failures proactively. And also, once the failures are detected, you have to solve them. Now, how will you solve a failure? Do you want to solve the failure in such a way that the same problem can come again and again? Or you want to fix the problem forever? In order to see to that the problem is fixed once for all, they developed a failure resolving methodology, and they called it MAC. In order to solve the problem in a permanent way, they developed a methodology called MAIC, where M stands for measure, A stands for analyze, I stands for improve, and C stands for control. You know why they started with a measure? What gets measured can only be improved. What gets measured can only be improved. If you can't measure a problem, it simply means you have not understood the problem. If you can't measure a problem, it simply means you have not understood the problem. So they correctly started with measure, and then they named this methodology as Six Sigma. They named this methodology as Six Sigma. Why it is Six Sigma? The naming is done based on the principle of normal distribution. You are seeing another gentleman here on the slide, right? The last person. He is nothing but Carl Friedrich Gauss, a German mathematician who introduced a theory called theory of normal distribution. According to him, all natural processes in this world follows a specific pattern. If you visualize the process, that will be in the shape of a bell. He named it as bell-shaped distribution or normal distribution. All of us unconsciously use this distribution in our day-to-day life. When I ask you how is your business going on, how do you say? Sir, the business is going normal, isn't it? And how is the patient? Now patient is normal. And so unconsciously all of us use this normal distribution every single minute. Imagine what will happen if you start using the same normal distribution consciously after mastering it, right? You will be able to solve problems better. You will be able to take decisions better, right? So it is your understanding of the normal distribution which is going to differentiate you as a black belt from other normal professionals, right? They may be having, a rich experience and on the domain knowledge and everything, the technical stuff is one side. Even after having, a lot of technical stuff, when it comes to problem solving, when it comes to project, and this problem solving skill makes a big difference, right? So problem solving and decision making skill will definitely make you a big leader. And Bill Smith and Michael Harry, they named this methodology as Six Sigma because they know that according to the principle of normal distribution, they know that if you run your process at a point which is at a 6 sigma distance from the customer provided or customer specified limit, your process will start producing defect-free outputs. Definitely, most of you will find it difficult to understand my statement, but to understand the statement, then we have to have at least another 1 to 2 hours of lecture on what is exactly Six Sigma. But right now, I'll repeat the statement. You try to understand, otherwise don't worry. Today afternoon, you will definitely understand. All that you need to do to produce defect-free product is run your process. We call it centering your process. Center your process at a point which is 6 sigma units away from the customer specified limit. Your process will definitely produce defect-free outputs. For example, a customer expects you to deliver the product within 10 days. And now tell me, how will you make a plan? Would you create a plan to make sure you deliver the item exactly, or manufacture the item exactly in 10 days? What is the number of days customer has given? Customer has given you 10 days of time. Now tell me, how many days will you plan to produce the products? Can I get some input from you now? If the customer wants you to supply in 10 days time, tell me what will be your plan. Will you also plan exactly for 10 days, or would you like to produce it within 8 days?
8 days.
8 days. Customer targeted value is 10 days. But where are you centering your process? You are centering your process in such a way that you complete little early. You complete little early. Why do you complete little early? If something goes wrong, still you have a cushion of 2 days. This is what is called centering your process at a point. That if you keep that point at a distance of 6 sigma units from the customer specified limit, your process will never fail to satisfy your customers. So this is what we call it, defect-free outputs. So Bill Smith and Michael Harry named the methodology as Six Sigma by knowing this, right? We will thoroughly understand how it helps us to produce the defect-free products with a beautiful example today afternoon. So this approach really worked very well in Motorola. Within a span of 10 years, Motorola made a saving of $16 billion, all through Six Sigma initiative. What is Six Sigma initiative? Doing projects. I do projects one after the other. We call it waves. The first wave, I do 6 projects in my company. All 6 projects helps me make a saving of 1.5 crores. And now next wave, there will be 18 projects. And when I do 6 projects, I require hardly maybe some 6 black belts or 6 green belts, and then few yellow belts. Now I do 6 projects. There will be a lot of saving to my company. And now my next wave will be 18 projects. Now my company needs at least 50 black belts. Now I will train more people. Why this training is required? If you expect somebody to work on a structured methodology called MAC, you need to tell them first of all what is MAC. You need to explain them what is measure, what is analyze, what is improve, what is control. Then only they can participate in your project. Then only they can produce results for you. So training is absolutely essential for the success of any Six Sigma project. So without training, people can do whatever they want and then can divert your project in a wrong direction. So training is an unavoidable thing for the success of Six Sigma. So they made it happen, and as a result, within 10 years, with several waves of Six Sigma project, they have made a saving of $16 billion for the company. It's not a small money those days, even today, right? And Motorola was awarded Malcolm Baldrige Award and the National Quality Award in the year 1988 because of the highest levels of standards they were able to maintain in their manufacturing practices, right? Because of the highest levels of quality they have achieved in their products and services. So they received the award, and today Bill Smith is known as father of Six Sigma. So Bill Smith is known as father of Six Sigma, and it is this person, Dr. Michael Harry, who developed the belt level. The belt level speaks about your ability to participate in a project. Participating in a project means your ability to contribute to the organization's growth. What is that your organization is expecting from all of you? An improvement. What is an improvement? My yield should go up, or my cost should come down, or my delivery or my lead time or cycle time should come down. If any one of the three you need to improve out of every project. No, that is why organization require professionals, particularly organization require people in managerial position. Maybe some technical jobs, I do not know. It is for some other purpose. But managerial positions, you have to make improvement. Either you improve the yield, or you reduce the cost, or you reduce the time. If you are not impacting any of the three, your services doesn't make any difference, right? So belt levels are created, and belt level will speak about your ability to contribute to the organization's growth. In fact, Motorola established a university called Motorola University, only to see to that all their employees are trained on this fantastic methodology called MAC, because MAC is a combination of various tools, statistical tools mainly. MAC requires a set of tools, mainly statistical tools, and then quality control tools, all your 7 QC tool. It is a combo. It is a combination of your statistical tool, quality control tool, and project management tool, and little bit of team management, because everything matters a lot. And then only changes can happen smoothly. Some of you spoke about change management. Change management cannot happen just like that. You have to manage everything to manage the change, isn't it? So that's the entire, everything is taken care with a structured approach. They named it Six Sigma, and it had 4 phases: MAIC: measure, analyze, improve, and control. So this is the story behind Motorola, and then later on Six Sigma became very popular, because if somebody succeed, obviously people will follow. That is what happened for the industries also. So somewhere around the 80s, Motorola introduced Six Sigma, and he is the key person behind the evolution of Six Sigma, Robert Bob Galvin. And then Allied Signal adopts Six Sigma. The key person behind is Lawrence Bosty. He was the CEO. And then in 1995, companies like General Electric, Philips, IBM, Sony, they also adopted. You can clearly understand now Six Sigma is not just restricted to automotive or only the manufacturing industry. There are different other industries are also falling in line. So it is Mr. Jack Welch, who was the CEO of General Electric. He appointed a lot of Six Sigma consultants to make sure Six Sigma is implemented left and right across his entire company. And it is in this period that the team of experts headed by Jack Welch realized that defining the problem is more important before measuring. Defining the problem is more important before measuring. So he added a D in front of the MAC. So MAC, 4-phase methodology, introduced by Motorola, was converted into a 5-phase methodology in the year 1995 under the leadership of Jack Welch in General Electric. Right? So MAC has become DMAC. Define the problem. Then you measure the problem. Then you analyze the root cause of the problem. Then improve. Improve is nothing but fix the root cause. That is called improvement. And then control the root cause. Your problem is understood. Now root cause also understood. Now you no need to worry about the problem. Rather, you worry only about the root cause. Control the root cause. If you control the root cause, your same problem cannot pop up again, right? So the MAC has become DMAC in 1995. And then somewhere around 1999, all the automotive giants like Ford, Toyota, General Motors, all of them adopted Six Sigma. And then companies like Xerox, bank like American Express, they also adopted Six Sigma. It is somewhere around 2000. People realized that integrating Lean and Six Sigma can help you achieve your results faster, because always people look for quick solutions. So we want great solutions. At the same time, the great solution should happen quicker, isn't it? So it is for that reason Lean and Six Sigma integrated. So implementing Lean will leverage the results of Six Sigma. Similarly, when Six Sigma is in place, implementing Lean can happen beautifully. So both of them were complementing each other very nicely. And as a result, from 2000 onwards, most of the companies trying to implement Six Sigma, they implemented it as an integrated approach called Lean Six Sigma. So we are going to thoroughly understand what is Lean, thoroughly understand what is Six Sigma, and so you yourself will understand why both of them got integrated. And it is the period around 2000, a lot of books started coming on with the title of Lean Six Sigma. So this is how Lean Six Sigma is born. Right. Now I'm showing you two different cars. One is Range Rover on the right side, and another one is Mitsubishi's Mirage on the left side. And tell me, in your opinion, which car is a quality car? Yes, I want.